Welcome to April 4th LeetCode Challenge. Swapping nodes in a linked list. You're given the head of a linked list and integer k. Return the head of a linked list after swapping the values of the kth node from the beginning and the kth node from the end. The list is indexed at 1. One index, just to say. So we have the linked list here, and we want to swap k equals to 2, so k is equal to 2, where one index, meaning that this starts at 1, so 1, 2, index 2 is being swapped with the beginning, with the kth node from the end, so the second last node. So swapping basically the kth node with the k size minus 2 as well. So swapping index 2 and index 5 minus 2, which is, no, 5 minus 1, I should say, would be index 4. So basically swapping this and this. If you want to swap the k index 5 here for this one, so it would be 1, 2, 3, 4, 5. So you're swapping 7 with 1, 2, 3, 4, 5. You're swapping 7 with 8 here, and you're swapping these two, which is seen right here. So that's pretty much it. The number of nodes is, the list is n, and k is less than or equal to n, which is both of them are less than or greater than or equal to 1 and less than or equal to 10 to the 5. The node value is between 0 to 100. So what we want to find is the kth node from the left and the kth node from the right, and then swap their values. First, since the linked list is indexed at 1, the problem is given right here, right? Indexed 1 indexed. The kth node from the left is k minus 1. And the node from the right is given in head node. So finding the kth node from the left is pretty easy. So to find k from the left would be called left equals to head. To find the left node, and then for blank in the range of k minus 1, and then we could update left to be left.next, essentially. And that's pretty much it to find the left node. So how do we find the kth node on the right side? So since we don't know the length of linked lists, it's not a straightforward way to know the length of linked lists if we just traversing along, because it takes a lot of time. It would seem that we have to find the tail node of the pointer and iterate backwards from there. So we're going to find the tail end of this. So the process for iterating through a linked list to find the tail node is it's called you can do like a pointer pointing to the node, a k minus 1, and the node to the left of the pointer, so we can search for the tail node that way. So that way we'll know the node, this k node from the right side, being the right node, and then essentially point it to the tail pointer node. So once we have both nodes, we can swap their values, right? And then that's pretty much the implementation of that. So let's find both the left and the right. So we have the left already, and then we say equal to the right. For blank in the range of k minus 1, find the left node and assign it to left.next. Next thing you want to do is find the kth node from the right. So this is for everything on the left. I'll just kind of make some notes here. Left node. And now for the right node. What we're going to do is assign a tail node. So we're going to call it tail, and we're going to assign it to 1, or left, I should say. And then while tail.next exists, so basically we're going to iterate through each of the node, which is not ideal, but it'll work. So we're going to update right and tail. Right is going to, and tail is going to be right.next. And right.next, and tail is going to be tail.next. So we're moving the 2 pointers, essentially. And then when we have While tail pointer does not have next anymore, that means we're at the end. And then we're pretty much gonna swap them now. So swap the values in return. So left dot value and right dot value will be right dot value and left dot value. Return head. So we're not really modifying the linked list itself, we're just swapping values, and that looks the same. Excellent. Let's see. Time complexity is big O of n, where n is the length of the linked list. Since we have to iterate through each node of the linked list to find the tail node. That's pretty much it for this one right here. Space complexity, or memory usage, is big O of constant space, because we do use 3 pointers here, which is left, right, and tail, which are the memory uses we use. Alright, that is it. Have a great day, guys.